Today we are going to learn one of the key assumptions in linear regression modeling. And that assumption is the homoscedastic assumption. The homoscedastic assumption requires that the error terms or the disturbances around the regression line assume equal variances. If they violate this principle, what it simply means is that there is the presence of heteroscedasticity in our model, and that presents some basic problems in the estimation process and may lead to biased estimation of our results. We have collected some data on the number of years a student has been in school and the hourly wage that the student collects as a result of the number of years that the student has been in school. And we want to use this data to test the presence of heteroscedasticity or to test whether our model satisfies the assumption of homoscedasticity in the data that we are relying on to estimate our model. So in this data, we have years of schooling and we have average hourly wage. And we want to, first of all, test the effect of years of school on average hourly wage. So with this, our dependent variable is the average hourly wage because it relies on the number of years a student has been in school. So we will be testing the impact or the effect of years of school on average hourly wage. So how do we go about that? So to test for the assumption of homoscedasticity, first of all, we need to run our regression model. And we run the regression model by simply typing regress, and then we state our dependent variable followed by our independent variable. Once we have executed the regression model or equation, we can proceed to state the test for homoscedastic, and we are going to be using the Bush-Pagan test for homoscedasticity, and that is specified as STAT HETTST. So this is the test for homoscedasticity. So the null hypothesis for this test says that there is constant variance. As we can see, when we executed the model, the null hypothesis says there is constant variance. And we can only reject the null hypothesis if our p-value is significant. Our p-value will be significant only if it is less than 0.05. In this case, our p-value is more than 0.05, and therefore we cannot reject the null hypothesis. In other words, the null hypothesis holds true that there is constant variance, and the homoscedastic principle or assumption requires that there is constant variance in the data. So with this result, we can be sure that our model does not suffer from heteroscedasticity.